Hello everyone, welcome to this webinar and thank you for being here today. In this webinar, we will go to see how to use the Implant platform to create a project for a photovoltaic system. The first thing you need to do is go to the website implantapp.com and log in. Of course, an account must be created if you don't already have one. Here you see your file manager, where you can find and edit all the projects that you have made. To create a new project, just click on the New button. At this point, the Google Map opens, and through the search bar, you can search for the address of your interest. In this case, we will choose this building here, so we will build a building with a pitched roof. Click on it to place the flag. Now we enter the name of the project, which in this case is webinar, a reference, LG, and click on create. Right now, Implant is cutting out a portion of the map and is downloading all the information relating to the data of the location we have chosen. Therefore, data relating to the surrounding environment, the horizon, the elevation, the solar orbits, and the irradiation. This process may take some time, but it is essential in order to obtain accurate production data. Here you can see the portion of the map that has been created. We are working in a 3D environment, so it is possible to move in 3D mode and observe some options that Implant offers. It is possible to activate the horizon, and you can see it turning around the real reliefs that you would find in this location. You can also see that we have activated the solar orbits. You can see the sun moving along its orbits during the hours of the day or during the months of the year. The solar orbits and the surveys provide data that will be used to calculate the production of the system. In fact, Implant, for its calculation, takes into consideration the nearby shadows given by the obstacles that we will place, but also the distance shadows given by the surrounding environment. Returning to the 2D mode, you can see here on the right all the options related to the environment. It is possible to replace the map with a transparent background or a colored texture. And it is also possible to select different map providers, even if the Google Map in most cases is the most up-to-date. We also have the option to add some media, such as images, to use instead of the map. We could then upload the floor plan of the building and use it to trace the perimeter of the building. Moving on the third icon, we can find information about the location, but above all, we can select the provider of the weather data. In fact, we have the possibility to choose between PVGS SARA. We can choose to use Meteonorm, which is a very renowned Swiss provider. And finally, Solcast, an Australian provider able to provide extremely accurate data on hourly basis, allowing us to work with data ranging from P50 to P90. All basic accounts can use Meteonorm data for free. LG Pros instead also have access to the most accurate data of Solcast. After this premise, we can start with the realization of the actual project. By clicking on the second icon, you will find some preset shapes. Otherwise, it is possible to create the outline of the building freehand, as we will do in this case. It will be sufficient to retrace the perimeter of the building in this way, simply by going to indicate which are the vertices and by clicking on the right button to close the shape. At this point, we can create the building and the roof. Here we have the icons related to the type of building, therefore whether residential or industrial. Obviously, the type of coverage available changes. Within the industrial one, we will find a flat roof, shed roofs, slopes, and barrel roof. Inside the residential buildings, we will find the automatic type, that means a pitch for each side, the double pitched roof, single pitch, and auto parapet, in case we have a parapet. In this case, we are going to use the automatic type. Simply enter some parameters, which are the height of the wall and the height of the roof, or the angle of inclination of the roof. In this case, we will set 7 meters as the height of the wall, for example. We enter an angle of 15 degrees as the slope of the roof and click on Create Building. We can see that immediately Insan automatically creates the building exactly as we have requested it. We can also go to edit the parameters we have entered. For example, by changing the height, it is immediately updated. Returning to 2D mode, we have the possibility to set the transparency in order to go and see if there are any obstacles on the roof. In this case, we have a chimney here, which I'm going to insert. It is very important to insert the obstacles, as this creates shadows on the system, so it is essential to check whether or not there are obstruction objects. To insert them, you need to move to the last icon, where we can find all types of objects, obstacles for the roof, for vertical surfaces such as doors and windows, and also trees that obviously can create important shading above our building. In this case, we are going to insert a chimney. It is possible to edit the size of the object from here, or you can take it and drag it into the scene and change the size by clicking on this icon, then going to stretch it or enter the correct size. The same thing can be done obviously for the height in this way here. Very good. At this point, since we have placed our obstacle, we can remove the transparency. Once the construction of the building and the positioning of all obstacles have been completed, we can already move on and create the prototype. What is the prototype? The prototype is the mix between the structure and the photovoltaic module. By clicking on this icon, we will find the different manufacturers of structures present on the platform. Or we can decide for a custom structure. Depending on the type of structure we need, we can enter all the necessary parameters and choose whether to use a horizontal profile or a vertical profile. By clicking on the icon on the right, we will have access to all the various module manufacturers. We will of course choose a LG module. Let's choose the Neon H Plus, which is one of the latest models released by LG. We choose the power we want, and we can see here a first information of the panel we have selected. By clicking on the information, we will be shown the complete datasheet of the module. Furthermore, Insan, by clicking on Module Preview, instantly creates a 3D model of the panel. We also have the possibility to explode it so that we can analyze the various components of the model. Once we are satisfied with our mix, we can, if you want, rename the combination and click on Create Prototype. At this point, our prototype is created and it will be placed in a list of prototypes made. In this case, the only one we have created is this one here. Now we can go and place the prototype directly on the pitch. We have two different insertion possibilities, the manual type or the automatic fitting type. In this case, we are going to use the automatic fitting. By clicking on this icon, we can highlight the pitch where we want to insert our models. Clicking on Calculate, the software optimizes the positioning of the models in the best possible way, giving us different parameters to choose from in order to install the panels as we prefer. Above, we can see the number of models and the power we would get with this positioning. We could, for example, tell the software not to place more than 6 kilowatts, until we see that immediately the excess models will be removed. Or we could apply different preferences, such as creating rows of panels of no more than 4 modules, for example, leaving a space between them of 50 centimeters. Clicking on Calculate, we can see how Implant creates these rows of no more than 4 modules, leaving 50 centimeters of space between them. We can also create a custom area where to place the panels in this way. Clicking on the pitch, we can insert a lateral offset, deciding, for example, not to place modules for a space of 30 centimeters along each side. And here we will create a new working area. The same thing can be done for the obstacle, therefore deciding not to place modules for a space of 50 centimeters around our object. At this point, let's proceed with the automatic positioning of the models. Here we have a first preview. We remove the filters we have previously inserted and see how the panels will be positioned. By clicking on Place, we can see that the window relating to the new field we are creating appears. We can decide to rename the field of models that we have created, and we have the possibility to define the temperatures used, knocked or sandy as standards, or we could customize them. By clicking on Save Field, we can analyze in the 3D environment the models that have been placed on the roof. And we can obviously decide to intervene on this system by eliminating, adding, or removing some models, like for example this model here that we can easily decide to delete. At this point, the fundamental step that must be carried out is to perform the shading analysis. We have two different possibilities to carry out the shading analysis. The first is directly on the surface. So even before placing our models, we have the possibility to check if there are any shading impacts due to nearby obstacles rather than distant obstacles, thus being able to decide in advance whether or not to insert the models in a specific area. Otherwise, we can carry out the shading calculation directly on the system we have installed, as we will do in this case, by selecting our area and clicking on Simulate Shading. At this point, it is carrying out analysis developed on the hourly irradiation data of each day of the year, applied to each single cell of our system. We can now see the type of irradiation that we get and where the obstacle is going to impact. In this case, on this model here. The analysis can be even more in-depth since Implant allows you to do an analysis at the cell level of the models, but also at the diode level. So in this case, we can see the difference having an half-cell models between one half of the module and the other. Based on this analysis, we can decide to intervene or not by placing optimizers rather than removing some models. In this case, we will going to eliminate these models in this way. By simply using the stretch command, we are going to reduce our rows. When making changes to the system, it is obviously important to recalculate the shading, as some analysis data may undergo variations. So we need to repeat the same operation again. Once we are sure of the positioning of the models, we can move on the electrical part. By clicking on this icon here and then on the field of interest, we can insert filters to choose and select the inverter that best suits us. Having in this case 19 models with a maximum power of almost 8 kilowatts, automatically Implant sets as a maximum value 8 kilowatts. We can then choose if we want a single phase or three-phase inverter and the voltage. By clicking on Go to Inverters, we can also find here the various partner and non-partners producers. In fact, by clicking on all manufacturers, we can search on all the producers present in the Implant catalog. In this case, we're going to select Fronius and we choose between one of their inverters. We will take this from 7 kilowatts with maximum power of 14, which is therefore more than enough. Clicking on Calculate, we are redirected to the page where it will be possible to assign the strings to the inverter and to the various MPPT of the inverter. Implant recommends the number of inverters needed. One in this case is enough, but we could decide to insert even more. We confirm and we can see the inverter number 1, which is our inverter, is divided into MPPT1 and MPPT2. 90 modules are the modules that we must go to satisfy, and by clicking on Calculate, the division is carried out by Implant, but obviously we will be free to go and set it manually as we prefer. The calculate function is very useful if we have many inverters, therefore for very large systems, where we can have a large number of inverters and the automatic calculation is very useful. Now click on Apply to Fields. Here we will find the inverter that we have set. We also have the possibility to insert some string boxes in case they are needed. In this case, we don't need it. We can just go back to the 3D view and manually place the inverter wherever we think is most appropriate. We can, for example, place it here and click on Assign all fields. We can see how Implant automatically creates a wiring in the most optimal way, which allows us to use as less cable as possible. But we can also decide to wire the cables in a different way, horizontal or vertical. Another thing that can be done is to select the drop point. Taking this white sphere, we can place where we want the cables to be dropped, and by clicking again on Assign all fields, the wiring is reset exactly with the setting we requested. When we are sure of the arrangement, we can click on Save Configuration, and here the project is almost completed. At this point, we can move on the document export part. And by clicking on our configuration, we have the possibility to export the documents, also including DWG files and a single line diagram. Export documents. The software reminds us that it is necessary to save it, and obviously, as with all software, it is always a good advice to save as many times as possible to avoid losing any data. Now we are redirected to the document export page. Here we can see the bill of material, that is the whole list of materials that have been used, including the connectors, the cables with the relative footage, the type of inverters we used, the models, and so on. By clicking on Next, we move to the real part of document export. The software is processing all the data of the system we have created, and here we can analyze all the most important information relating to the system created. We will then have the specific production, the annual production. Remember that these are data validated by Fraunhofer, which is, as you know, one of the major research centers, at least in Europe. So we are sure that these export data relating to the production of the plant are very, very accurate and almost identical to what they will be in reality. So here we have all the primary information. Here you can find the information about the weather and the weather provider. The information relating to the slope and the solar impact we have. The inverter that we have used. And here we have the production data of the system. Then the breakdown of the month by month and the annual production that we are going to get. On this other graph, it is very interesting to note the impact of nearby shadows and distant shadows, the angle of incidence, and even in some calculates soiling as snow. Here are very, very important data, which we talked about before. It is the mismatch calculation that InSum performs automatically. This entire documentation can be downloaded and printed in order to give it straight to the customer. Now we can activate the self-consumption part. Very, very interesting with regard to consumption is that we have the option to enter the real consumption data of a particular property, deciding to go and calculate it, or we can even upload a load profile. So if we have a CSV file or an Excel file, we have the possibility to enter the consumption at the hourly level. Otherwise, we can decide to calculate the load profile. For this, we have three different entry methods. We can enter the annual consumption not divided by bands, the annual consumption divided this time by bands, or even monthly consumption divided into 3 bands, F1, F2, and F3. To be quick, we are going to insert 3 different data, band 1, band 2, and band 3. For example, let's assume more or less random consumption that serve only to demonstrate that immediately the system provides us with a load profile respecting the data we have entered. Here you can see the profile generated. We have the possibility to indicate how our consumption are divided. Going to indicate the various appliances that will have an energy impact on the building. For example, we can decide to remove the induction and check the load profile again. Once this is done, we can reload the graphs that InSun offers to us. We can see that we are given a monthly and yearly production file with an average consumption and an average production. Here we will have a self-consumption of 82% and an energy fed into the grid of 17%. And here we can check how much energy is withdrawn. We can, in the same way, analyze the production bar chart and then fully evaluate all types of charts that are released to us. Each of these graphics can be exported and printed. Another fundamental step is the one concerning the financial field. By activating the flag on financial and moving on to the financial part, we have the possibility to hypothesize and calculate the complete cost of a plant. So putting in a cost per kilowatt peak, which could be this here, an annual maintenance cost, the cost of the battery in case we had one, and so on. We can also hypothesize a loan, then entering the financed amount, for how many years the credit is granted, and so on. Another very important thing is the possibility of calculating a possible grant by entering the duration and the percentage we have access to. For example, we can assume that 60% will be recovered over 10 years. We must then also enter the cost of electricity, which at the moment is increasing dramatically. A selling cost for the energy that we overproduce and that we go to sell to the supplier. So on the basis of all the data we are going to enter, so the most accurate the data we enter and the more accurate the response data we will receive from the software, a repayment plan is immediately created. In this specific case, we can see that in the 5th year with our system, we would already go positive and we would go to recover the investment we have made. The yellow part would be the grant we had access to, which then ends in the 10th year. The analysis is done over 20 years, as we have set here to run it over 20 years, but we could also have changed the value. We can see that at the end of these 20 years, we will have a profit of over 23,000 euros. At this point, we have the benchmark feature that we have developed exclusively for LG, where you can compare different models with each other. I will show you soon. First, I would like to show you how Implant takes into account the bifacial factor, quickly creating a new implant. To do this, we are going to create a new layer. By creating new layers, the system maintains the construction we have built and removes the created system, so that we can try out different types of structures and photovoltaic modules. So when we create a new layer that we can rename, in this case, bifacial, Implant will eliminate the previously photovoltaic system while keeping the building unchanged. In this case, however, we will realize a new building, this time with a flat roof, in the same way we did before. This time using a preset shape, which we simply position on the scene, and we go to rotate in order to align it with our building. We can now stretch the sides of the shape to cover the building we chosen, like this. And then we go to create a new prototype. This time we are going to select a bifacial, which could be this one here. A 20-degree structure should be fine. Let's rename our prototype bifacial and click on Create Prototype. At this point, we can see that in addition to the prototype we have created before, there is also the new prototype. Now, let's go to complete the building. We need to enter only two data, which are the height of the building and the height of any parapet. Create building. Immediately, we can see the new flat roof building completed. By selecting the bifacial prototype, we can, exactly as before, use the automatic fitting. By clicking on Calculate, Implant automatically aligns the models to the south, but we could decide to align along any side of the building. Also in this case, we can set some lateral offsets, for example, 1 meter, and create the new work area. Once again, set all the filters we might need and click on Place once satisfied with our disposition. Just like before, let's save the new field.
Fundamental this time, in order to use the bifacial correctly, is the possibility of changing the type of coverage. We know that the bifacial works on the basis of the eye radiation reflected on the back surface, and it is essential to have the possibility to use different types of surfaces, which obviously have a different albedo. Higher is the albedo, and higher will be the production of the bifacial model. I'll show you the difference by first entering a coverage with an albedo of 0.2. The albedo can obviously change it manually. Let's carry out the analysis of the shading exactly as we did previously. Let's go now to choose the inverter we want to use. In this case, we have a 25 kilowatt peak system. So we can go to select a 20 kilowatt inverter as it has a maximum power of 30. We are moved to the page, the strings assignment. One is number of inverters recommended. Also in this case, we have 2 MPPT for a total of 56 modules to satisfy. We can, for example, divide them like these. And exactly as before, we are going to place the inverter within our scene. Let's assign the cable wiring again. Save configuration. Let's now export the documentation. Always saving first. Next. We can note in this case that the bifacial factor is calculated. Therefore, the production that we obtain using a bifacial model, that in this specific case is 31 megawatts per year. If now we go back and we go to modify the surface of the building by inserting a surface with a higher albedo and repeating the same operation we have just done, next again, we can see that our annual production has risen to 37 megawatts, and the bifacial gain increased to 372 kilowatt hours per square meter. Now I'm going to show you the benchmark feature. With a repeat is specific and exclusive for LG, so it is allows you to compare an LG model with models from other brands. Here we have search filter that help us speed up the search within all the models present. For example, we can apply a zero tolerance regarding the power, and we are going to choose a module of the same power as the one we used. Let's select a Canadian model, for example, and click on Performance Benchmark. Right now, Insan is carrying out the production calculation on the entire system, first for our LG model that we used, and then for the model that we have selected to make the comparison, which in this case is the Canadian. We can see from the document that is exported that by using an LG model, we get an increased production of 26%. This is the energy produced over 25 years. Thanks to this feature, you can see how actually LG models are, in most cases, convenient than a model from another brand. At this point, I have shown how to create two different projects in a very, very fast and very, very accurate way. I remind you that all the documents that have been produced can be saved, printed, and delivered directly to the customer, including DWG tables, including single line diagram, and above all, inclusive of the annual production, which I repeat once again, calculated based on algorithms of calculation validated by the Fraunhofer. I hope I was clear enough. I invite you all again to go to insignapp.com and immediately start to use the platform. Thank you very much for the attention.